Hello, today's topic is about I've taken one topic from electronics, AEC, extrinsic semiconductors. So, what is a semiconductor? First, we have to check this. What semiconductor actually mean? So, the devices, so the substances that allows heat or electricity electricity pass through it to pass through it is called as semiconductor. Okay, so the example basic example of a semiconductor are silicon and germanium. So what type of material uh, does semiconductor include? So it can be made up of mm, the silicon, or it can be made up of germanium. Okay, so now we will come to the extrinsic semiconductors. So by the word extrinsic, this word extrinsic, what do you mean? It means that has been doped. The type of semiconductors that has been doped has been doped so that they can have impurities. So why they are doped? So the question arises why they are doped. So it is so they are doped because to increase the resistivity of the material. Or you can say that they are doped in order to modify the modify electrical electrical properties of semiconductor material. So this was about extrinsic semiconductors. So further, there are two types of two types of extrinsic semiconductors. So the first one is N-type. N-type semiconductors. And the second one is P-type semiconductors. So in N-type semiconductors, the concept of in N-type concept of pentavalent elements comes okay by pentavalent elements. What do you mean? Elements elements having five valence electrons. So the pentavalent elements are phosphorus, or arsenic. So these are basically impurities. Okay, basically are impurities. So why these are added? To increase the resistivity of the semiconductor material. Are added to silicon or germanium. So silicon or germanium are considered pure semiconductor materials. So in pentavalent, 5 electrons are in the outermost orbit. So let's discuss how the impurity is added to the silicon. So let's taking silicon and phosphorus is taking place at this. So we have already discussed that pentavalent impurities have 5 valence electrons, that, or we can say that 5 electrons in the outermost orbit. So this is one electron, this is second one, this one is third, fourth one. So it's creating a bond with the silicon atoms. So the seats are already covered and one remaining electron will be in valence orbit. Okay. So this electron will be a free electron which is of phosphorus, and it will roam around in the structure, the given structure. So in n-type semiconductors, electrons will be majority carriers and holes will be the minority carriers. Okay, so we discussed about the n-type, or we can say negative type semiconductors. That was one part of the extrinsic semiconductor. So let's get on to the second one, that is p-type. In p-type comes the concept of trivalent elements. By trivalent elements, we mean elements having three valence electrons. Such as boron or aluminum. Which are added to pure semiconductors. Material such as silicon. So let's get on to the crystal structure of p-type semiconductor. So taking the silicon and aluminum will with three electrons, one, two, and three. So it will create a hole because one vacancy is remained with the silicon atom. This one is called the hole. So we discussed the n-type and p-type semiconductors of the extrinsic semiconductors. So do share, like and subscribe. Focus Leaks. Thanks.